Hello everybody, this is Cameron Snow with Danomics.com. In this video, I am going to be talking about how we get your data interpretation ready within Danomics. So you're ready to start a new project, you've got a bunch of LAS files, you've loaded them up, and then you realize they're a mess. Well, what is it you do at that point? Maybe these things have all sorts of different curve names. They're in different units. Some things are, let's say a bulk density. Others are density porosities. Your SP needs to be baseline. There's washouts. You just don't know where to start sometimes. Well, this is where Danomics can come in and make life a lot easier on you. So there's really two ways we can do this in Danomics. There's the easy way and the really, really easy way. So I'm going to go over the easy way because it's a bit more thorough, but this will still only take just a minute or two. That's how powerful this can be within Danomics. So what I'm going to do is I'm going to start off here with a flow. And what a flow is it is a set of tools that perform specific operations on your logs. And so what we would do in this flow is we would start off by bringing our logs in. Then we might want to fix things like log depth problems. So for example, your logs, even though they're supposed to be in ascending depth, sometimes that gets screwed up by the service company. So we're going to fix that. Then we're going to go in and we're going to handle all the units. So we're going to look and see, hey, are things decimal or are they percent? Are all our gamma rays in API units, or do we have some of these really old logs that are in micrograms of radian equivalent or whatever? So we're going to go through and we're going to handle all of those. And we're not only going to do that, but we're also going to make all the units have similar names. So, if you think about something like percent, is it, written out percent? Is it PCT? Is it, PERC, etc. So we're going to handle all those conversions and we're going to rename those units because that'll make it a lot easier going forward if you want to take your logs into some other program. Now there are times when we have curve name collisions. So for example, if you have a log that's called GRD, is that a guard resistivity tool or is that a gamma ray tool that was ran with the density? Well, a lot of times, this can cause problems. So we go through and we check the units and curve descriptions, and we sort that out for you. Also, when you're logging porosity, this often comes with a matrix lithology. So, was it logged in limestone, sandstone, or dolomite units? Once again, the curve names sometimes reflect this, but not always. And so we're going to go through when the curve names don't make that obvious, and we're going to read the descriptions, and we're going to look at the curves and try to help sort that out for you. We do the same thing with the resistivities. We go through and try and understand, is it an induction log or a ladder log, and do that type of renaming, because that can be important if you're working in a basin like the Permian, where they logged the upper run, as one log type and the deeper run as a second resistivity type. It can lead to having bullseyes in your interpretation. So we want to be able to handle that and understand what's going on there. Now, a lot of times you get flat spots either at the top or the base of your well logs. So we're going to go through and we're going to trim off those flat spots. We're going to fix the drift in our SP curve by applying a baselining to it. And then we're just going to do a little bit of housekeeping by removing all the null logs that are in our database. And finally, we're going to write out this QC database. So we do that, we hit the run button. It just takes a few seconds here in Danomics. And then we've done a first pass cleaning of our data. And this will make things quite a bit cleaner for you right off the bat. But there's a lot more that we can do in Danomics. So once we've pulled that cleaned database into Danomics, now we're ready for a lot of other things to happen behind the scenes. So when you start a new project in Danomics and you pull in that database, what does the software do for you? Well, first of all, we handle curve aliasing. We have a a very well curated alias table of almost 10,000 curve mnemonics to make sure that we get everything in the right namespace. This is, of course, user customizable, so you can have some control over this. But without you doing anything, you should have a 99% catch rate on most vendor-supplied logs. So we handle that curve aliasing for you. We also handle curve type conversions. So let's say you have a DeFi sandstone, a DeFi limestone, and a bulk density. Well, we convert everything over into bulk density space for you. So we handle that part of the cleanup. Also, some tools like the Neutron, maybe you have some that were logged in limestone reference, some that are logged in sandstone reference. Well, we handle that conversion for you, so we get everything in the right lithological reference space. And this is without you having to touch a single button. This just happens. Also, although we've already handled units, we'll do a second set of checks here in our petrophysical interpretation before we get started. It'll do things like checking curve statistics ranges to make sure that something that was labeled as maybe decimal is actually decimal. So we'll check some of the stats, make sure that labeling was correct, and we'll do the conversion if needed. And then once we've done all that, now we're ready to start addressing some of the, let's call it data problems. So one of the biggest problems that you'll run into is that, you've got curves that have been, that come from different vendors, they come from different age tools, and they don't always line up very well. So most commonly we see this on the gamma ray. So a lot of times we'll see gamma rays where if we look at them from multiple wells, we'll see that they don't line up, they don't match very well. So we want to fix that. Well, in Danomics, we give you a number of different options here to come through and normalize your data. You can shift it, do a 2-point stretch and squeeze, 3-point stretch and squeeze. You can scale it to fixed values or fixed ranges, and we can do that using offset wells if we choose to normalize using a grid. With the simple scale, for example, this is one of the more popular ones, and it's done with just a single click. We set that, we say what percentiles do we want to align our data on, and then we can come over to our cross section and we can view that normalization, and we can see that we have some logs that are shifted a little bit lower, some that are shifted a little bit higher, and we can tell this by the shading here. We're showing the normalized and unnormalized curves. And so we can see how that stretch and squeeze has been done. And then if we see a log where we think, we might need to go in and, take a manual look at, we could always go in and do that. We just click on that well and say, okay, is there something different here about this particular log? And we could take a look at that. So that's how normalization works. And once we've normalized our data, we probably want to do some repair of the washouts. Okay, so how do we do washouts in Danomics? Well, let's take a look at some of the methods that are available to us. So first of all, we can look at things like the rugosity of our caliper curve. We can look at minimum and maximum density values that we'd like to accept. We can look at the D-row curve, that's our density correction. We can also decide whether or not we want to flag washouts for both our neutron and our sonic as well. Now, although those curves have a much deeper depth of investigation, sometimes in really extreme cases they can be affected. So we can look at those as well. And then what do we do once we flag that washout? Well, what we do is Danomics will actually go through and it'll build every possible combination based on your available data, using either multilinear regression or random forest, and then select the model that gives the best fit to the non-washed out data, and then apply that model to where we have washouts. And this is actually a really powerful tool, so we can look at this and we can say, hey, here we have this washout, we don't have, 30% porosity rock anywhere in here. So we flag this as washout. We let the system apply this automatic repair to it. And, now we get rid of those anomalous porosity streaks that otherwise would most likely show up as net pay once we get to the end of our mapping. The other thing that we can do here is we can essentially infill gaps within our logs. So, let's say we had a bit of missing log here in our density. Well, with Danomics, we can automatically use that machine learning model to infill gaps in your logs as well. And once you've got this done, you're ready to do some QC work. So what is it we can do? Once again, we can come back to our cross section and we can QC here and say, hey, where do we have a lot of washouts? Oh, we got them here in the muddy formation. Are we doing an adequate job, repairing those washouts? What are we doing in some of these other formations? Where do we see big changes? Maybe we want to go in and QC some of those. Once we've done that, we can also go in and we can QC things on the map. So here I'm looking at a QC of my bulk density. Maybe I also want to go in and say, hey, let's look at a QC of my neutron here, and I'm going to have to change my scales, but we can go from 0 to 0.4 and looking at 2 porosity units, and we can go in and QC that as well and see, hey, where do we have higher and lower values? Is there something in particular we need to go look at here? All right, and once you've done that process, then you're ready to start your interpretations. All right, well, I hope this video was useful to you. I hope it gave you a few things to think about when you're starting a project and you're getting ready to get ramped up and you need to get your data ready to interpret. This is something where I just see customers across the board at Danomics getting a lot of value out of this. And if you're not a customer, I'm happy to show you how this can help you get your data ready to interpret as well. All right, thanks.